Hi everybody, we'll be beginning very shortly. We're just waiting for a few people to join in. We already have a decent crowd here online and we're expecting a few more based on the registration we have had received. So in a minute we should be starting. We'll be discussing Docker containers and virtualization using classic virtual machines. And we'll compare and contrast these two techniques of deployment of applications. And I think most of you probably understand the virtualization part already. So I'll probably tend to focus more on Docker containers, give you some core concepts, help you understand how to use it. And at the end, we'll also have a live demonstration of a application that we'll do, containerize it, and run it in multiple tiers. So we'll have multiple containers running different parts of the application, and you will see, and there is a sample code available already. So that's what we intend to do. We'll begin shortly. Happy to see all of you. Yeah, we are streaming from the Seattle area. Seattle area is known for not just cloud computing companies, but also for being cloudy. Yes, it's a cloudy area. Yeah, the sky is just covered in clouds all the time. That's the only drawback that I think I know of this area. Otherwise, this area is stunningly beautiful. And the city where we live is considered one of the best places to live in the US, and also the friendliest place in the US, like number one, which is amazing. This city is, by the way, Sammamish, where we live. I will remember to record this session so that you can at least have a copy of that in case we need to have a rerun. All those cases, it helps to have a record. So I'm going to record this entire webinar as we proceed along. The agenda that I briefly already mentioned will focus on understanding differences between containerization and virtualization, identify pros and cons of each, and understand which is the most appropriate vehicle for a given application deployment scenario. And we will play more with containers than with virtual machines because I'm suspecting most of you already know what virtual machines are. You probably have used them. And containers are relatively new in the news, I should say. Their container idea is not new. But that concept of Docker and all the containers, and there is a lot of buzz going around it. And so it is good to clarify what these things are and how do we put them to use in a real life application. As an example, there'll be some sample available for you to download. And we have a virtual workstation already prepared with Docker. So you can play around with the code that I'm going to provide to you. And so you will benefit if you actually download the code and use it with a ready-made workstation we are giving you and run these exercises yourself so that you get a real feel of what we are actually going to deal with. And you can always chat with us anytime you have a need for something. If you run into an issue, you can come on to our Slack chat channel. The chat channel is actually available on this link. If you can go here and go to this site, it is simple, chat.cloudgenie.us, and here you can just type in your email address like this and invite yourself, and you can just come on chat with us. So that's how you can ask and receive help if you need something. If you get stuck somewhere along the way, you can do that. And as we proceed in this webinar today, it'll be a great idea to just make sure that you avoid distractions, keep focused on what we are discussing. And there are a few more folks who are going to join. I already see a large number of people, from multiple countries. That is just awesome to see all of you here, and that's just beautiful. So, by the way, while you are at it, make sure that you please share this webinar. Share it with your friends on LinkedIn, Facebook, Twitter. That helps so that people will understand what these technologies are. We primarily focus on open source technologies and tool sets at Cloud Genius. And that is our primary agenda, is to make sure that there are these gems, nuggets or whatever you call it, beautiful ideas implemented in terms of open source projects available worldwide on open source sites that you can think of: GitHub, Bitbucket, and GitLab, all those places where you can find these tool sets. Communities are creating multiple different products, multiple different technologies, and that's what we primarily focus on, is open source and making sure that people are using them in enhancing and furthering their business goals. That is our primary focus at Cloud Genius, by the way. And Docker is an open source product. released initially by .cloud, which is now the company's name is Docker. The product itself is open source and is available on GitHub and through this website, docker.com. And so by the end of this session, you will know differences between virtualization and containerization. You will also have a good understanding of what containers are, specifically Docker containers, how to run an N-tier application inside containers, and when to use virtualization and when to use containerization. And before I begin, let me just briefly introduce myself. My name is Nilesh. I used to be an IAS topper back in India. This is like 19, 20 years ago, so it's an old story. But then over the years, I have worked in multiple companies, EMC Corporation, Microsoft Corporation. I've been a product leader in built multiple products such as the Lync application you may have heard of. Skype for Business is the new name these days. Windows 7, Office 365 is where my patent is implemented across the board on presence detection. Also in Lync, and if you see those bubbles, red, green, the colorful bubbles that you see, the implementation of detection of physical presence is a part of my patent, which is now assigned to Microsoft, is implemented across the board in Office 365 products. I also have worked on storage products from EMC, the flagship product, which used to be $1 million box 15 years ago, called Symmetrix. And for the last few years, I've been focusing primarily on Cloud Genius to help you accomplish the cutting edge technologies, make sure you're highly productive on using cutting edge technologies in your job. That's my primary focus. That's the focus of our team also at Cloud Genius. You can connect with me on LinkedIn. Here is a link at the bottom, linkedin.com/in/my last name, LONDHE. That's how you can connect with me, and I welcome invitations. Cloud Genius, by the way, has been rated one of the top 10 programs in cloud computing. It is also the fastest way for you to become highly productive with cutting edge technologies on your job. CIO Magazine, the magazine on information technology, they have rated us as a top 10 cloud program, which is just beautiful. And I think that primarily happened by the feedback that we have received and CIO Magazine received from our graduates who work at multiple companies. Like, we have Boeing company. The chief architect on cloud computing and his team members are in our program. They have graduated from our program. Hitachi Data Systems, their architects are also currently going through our program. Expedia, we have a senior director who is in charge of their Hadoop data cluster. Big data cluster using Hadoop is a graduate. His team members have attended our program. We have people from Microsoft, CA, Inrix, and a whole bunch of other companies already have graduated from the program. They have taken these ideas and implemented what we have provided in terms of training, in terms of consulting back in their companies, and have gained tremendous advantage. That's one of the fundamental reasons, I think, why these CIO Magazine rated us among the top cloud training providers. So having said that, let us focus on what am I going to demonstrate, what am I going to really talk about today. And that we already said, we'll skip the demonstration on virtualization because I suspect you probably already know that. So I'm going to skip that part. Focus on containers primarily. And so before we jump into the actual demonstration, some of the core concepts here coming up. What do you need in order for you to run these things that I'm going to run for you? You will need some kind of a laptop, desktop, a decent modern machine, maybe 1 or 2 years old with about 4 to 8 GB RAM. That'll be nice. It doesn't matter whether you have Linux or Windows or Mac, because we are going to give you a workstation. This is going to be a ready-made machine that you can install on top of your laptops. We'll also give you a code sample you can run. That's the exact code that I'm going to run. I'm going to give it to you in form of download. You can try that yourself. And you can experiment with the same code that I'm going to demonstrate right now. Optionally, you can take the same code and run it on a cloud service and have the exact application that I'm going to run it on a cloud scenario. You can choose any of these cloud providers. It doesn't really matter which one do you use. Anytime if you have a question, you can just hop on Slack chat. Slack chat looks something like this, and there is this general channel. Here you can just chat with us and talk to us in terms of any questions you might have. So come on Slack, chat.cloudgenie.us. That is the address where you can invite yourself, chat.cloudgenie.us. This is the location where you can invite yourself. Having done that, let us understand core concepts in terms of these technologies. So what we are really talking about is running some applications, libraries, runtime, the underlying operating system, and all of that on top of some set of resources. Resources, by that I mean, things such as, core compute capabilities, storage capabilities, networking or interconnect capabilities. These capabilities you might have in your data center, in your environment in the cloud. And you want to basically allocate these resources and associate them with some application that you might have somewhere that you want to run. And you want to be able to run these applications, libraries, runtimes, and operating systems on top of these resources that are already available to you somewhere. The best way, and there are several ways to do that. One of the ways that you probably know already is this classic way of dividing the resource underlying into several different parts. And in each box, in each silo, if you think of, you will first install the operating system, put libraries and runtime on top, and then on the very top you will have your application. And you will repeat the same game in the another virtual machine. For example, you will put some OS and then put libraries and runtime and put your second application on top, and that's how you keep building, and you have a large collection of virtual machines. And this is the classic virtualization model. And this is very appropriate if your underlying operating system is not Linux. You want to run Windows here, for example, like this. In that case, you absolutely have to have virtualization, because Windows does not work in containers, at least as of right now. It might come in the future. I hear 2016 or something. It is probably coming. But until that time, Linux, if you have, then you can use containers. If you have Windows, stick to virtualization. That's the way to go. Now, having said that, if you have this commonality where you have Linux at the underlying OS all along in every virtual machine that you're running, by the way, most of the cloud, or maybe 70 to 80% of the cloud computers, by the last count that I saw, is actually running Linux already. So if that's the case, you are now dealing with a new kind of problem, which is what I call the department of redundancy department. There is a lot of redundancy going on here, where you're basically repeating the Linux OS over and over and over again. Some common libraries and some common runtime is again repeated over and over and over again in different virtual machines. You can reduce some of that very simply by going to a different model of identifying common libraries, going to a common base of Linux OS, and then carving out independent containers in which you can run specific libraries and runtimes and those applications that need them in separate little containers like these blue boxes showing here. And that way you can cut down on some of the redundancy. That's the core idea behind containers. So if you look at further detail on a pictorial representation in a stack form, on the left side you have virtual machines, which is basically you have a server at the bottom, some kind of a host operating system, and then you have a layer of hypervisor. This hypervisor can be, XenVM, Microsoft's Hyper-V. It can be VMware. There are a bunch of different open source hypervisors available that you can use like this. And then on top of these, you carve out virtual machines, and then you put guest OSs and binaries and libraries and apps and all that. And then that's the classic virtualization model. Whereas in the container model, you have the underlying server, which is typically Linux. That's the only choice right now, by the way. That's the commonly used choice, I should say. Host operating system will become Linux. And then you have your Docker engine that runs on top. And this provides you the ability to actually put things inside containers. So you can put binaries and libraries and applications on top within the containers. And that's how you enable the scenario, which is in a container scenario. So having studied that part, let's move on to what exactly this Docker thing is. So from a product perspective, Docker is an open source product. It has these two basic components. One of them is this Docker engine, which is basically allowing you to create containers. And on the other end, there is a Docker hub. This is like GitHub, if you will, Docker hub. And this hub is where people share images, either within the company or outside the company, or within a team, outside your team, share it private, share it public. Those capabilities are provided through this hub. And here you can find a bunch of different images already available to public at large. And you can put your own custom images and save them here, share it with your team members, or share it with public outside. That's the idea behind this Docker Hub. Now, what does Docker really do? You basically get to run your applications inside little containers, and you can manage the underlying imagery, the underlying operating system images, through a registry such as the Docker Hub, which is this site here. Or you can create your own private registry if you want to be all private within the firewall, within the company boundary. You can do that way also, not a problem. Both models are supported. And once you have these containers and images, using the images ready, and then you create containers using those images, you can then link containers, such as in the example here, Node linked to Mongo. That's just one example. Next up, the concept of Docker and this concept of images becomes feasible by an underlying file system which is unique to Docker capability, and that is basically the Docker file system. And it is a file system that allows layering. What does layering do essentially is that you can have at the very basic, at the foundation, you have the common kernel, and then you can start layering a BusyBox image, and on top of that you create a writable container. Whereas on the other end, you put Debian image on top, and then you add some applications on top, and then at the very top you can keep writing. So anytime you write something, it creates a copy. That's the copy on write technology. That is what is used. So for example, here in this, you begin with the boot file system, a root file system, put say Ubuntu operating system on top, install some applications, set some environment here, and then run some command, say for example the Apache server. And that becomes your application number one. You can freeze all this in form of an image and put that as a foundation for a second application. So in the first application, you have Apache loaded up. You can take that as an image, the my app one image, put that here as a reference, and then build on top and do something like add your application, git clone, mount a folder, and run that command Apache, which is actually available here in this image. And you can then create your application number two. And so you're building a layered structure. In this way, you can actually optimize and use other people's work, or maybe your own prior work that you may have done. This is a construct in which images are basically layered on top of each other, and that cuts down some redundancy. And so you can put these images inside public or private registry, your own hub if you want, or you can just use the public hub which is available to us on this site, which is hub.docker.com. And most of it is free. If you have to have private repositories, I think you have to pay them money, or if you like, you can run your own private Docker hub or registry for yourself in your company. Not a big deal at all. Having said, the concept of starting a container using an image goes like something like this. On your Docker client that you run on typically a Linux box, you invoke, say, Docker run some application. So Docker run web app, that's my command, and it will instantiate this container and it will run the web application. Next, you can then say, I want to add Docker run DB, so run my database, and that's where it runs the database. You can say that, you know what, stop the database, and the database goes away. The web app still exists. And you can keep on administering whatever you want to create or destroy, just as simply as create an app, create a DB, destroy a DB. This is just stopping a DB, you can destroy it also. And that's the concept behind orchestration. Now, having said, these images that we are talking about are more like templates that you have in virtual machines, but these things behave like code because they are copy on write. They create a copy, so you cannot destroy the underlying layer, but you can always create a new layer and then write on that layer. That's how this layered file system structure is implemented inside Docker in the technology that we're talking about. So now it's time for demonstrations. So let's go look at some demos. And this is my favorite picture where this guy is going to mix cornflakes in milk and it is going to catch fire. I hope I don't have that problem, but let's see. So we'll begin with a basic simple demonstration inside a workstation we already have. This workstation is the CloudGenius workstation, which you can download from our site /workstation, and that's the link. So you just hit there, And in that location, you can grab this virtual machine that kind of sort of looks like this. And there are two steps, 1 and 2, and that these two you follow for downloading some application and an OVA file. Once you have the OVA file downloaded, you just import that into VirtualBox to create the ready-made workstation that looks like this. And this is a Linux machine. It already has the code preloaded, so I'm going to just use it and show you the demonstration, but that's the machine that I'm going to talk about. That's the machine I described, is that you can also download from this site location, and you can get that link, bacloudgenie.us/workstation. That's the link. It will also be in the notes. Now, having said that, we are going to begin using Docker. Very simply run this command, docker run hello world. That's my plan. So I'll go to my workstation, which is here, and say docker run hello world, and compare. Yes. And so back to the machine, I'm going to just run it. When I run, this hello world is actually a reference to an image that needs to be available to my machine here. And if I have it, it will just run and it will say hello or hello world and exit. Whereas if I do not have the hello world image on my laptop on this machine, then it will go to that Docker Hub, download it, and then run it. So let's see what happens. So I'm going to invoke it. I don't think I have that hello world image here, but I'm going to just run. And so here we go. It's unable to find that hello world image locally, so it is going to go to Docker Hub and pull it down. After it pulls down, it runs it, and then it does whatever it's supposed to do, and then it is done. And so then it says, okay, I'm done, and quits. That's exactly what just happened. So you can see that hello from Docker, and this message shows that your installation appears to be working correctly, which is nice. And then this is the output. You can there are some examples available, and then it quits. You can see that currently Docker PS does not show us anything running, because this particular container that got created, the name of the image was hello world. It was pulled down from that library, which is Docker Hub, and this image is not available locally, so it is now available though. So this time if you run it, again the same command, docker run hello world, boom, it just runs quickly because you have the hello world image locally available on this workstation. Now, it was not there to begin with. Having done this part, we see that this process already exited again, because that's the purpose in life of that project. That hello world project is to just print this output and die. And so it prints this output and the process is dead. Let us check our dead processes. So docker ps-a, and here you see that there are two dead processes. One of them is this ID and the other one is this ID. Both of them were hello world image based and they are dead. So that's the way to run a quick invocation of an existing ready-made image available to us on the Docker library, which is the Docker Hub. And the name of that image that we have now is called hello world. Now let us see what images we already have on this workstation. So I'm going to clear and say docker images. What do I have? Looks like I have lots of different images here. So I have a BusyBox image and a WordPress image and a MySQL image 5.7 and a MySQL latest and hello world we just have downloaded now, and like that. So the idea is to download these images. You can pull any image you like, such as docker pull and Ubuntu, and this will pull down the latest Ubuntu. And do we have Ubuntu here? Yes, we had. And so it was basically matched up. It already existed. All these references already exist. By the way, these are the layers in that file system for Ubuntu. These IDs are indicative of the layers in that file system of that image. So now image was up to date. It matched up. The digest matched up with the Docker Hub, and it says image is up to date, nothing to do. So it did nothing. Your local image was matching up with the library image Ubuntu. And that's what we just finished doing. Now, let us run a simple container, but this time we want to run it interactively as opposed to a container that says hello world and dies. I want to actually invoke a container based on this Ubuntu container, Ubuntu image, and run some interactive command on it. So a simple way to run that will be docker run -i for interactivity, T for teletypewriter, and then I want to run this Ubuntu OS. And in that OS, when I invoke this Ubuntu image, I want to run the bash process. So I'll say bash, and here I am running Ubuntu. You can verify that. By the way, the virtual machine also is Ubuntu, so there should not be any confusion. So I want to clarify that. And how will I do that? How will I prove essentially that this machine, that one I'm running, this one, is not the same machine that I am running here? This machine is my workstation, whereas this terminal prompt that you see is actually this bash prompt that you obtained inside the container, and you can verify that by doing a very, very simple trick. One of them is to just say cat etc release and see what version of operating system we have. So this is the LTS version, trusty version of Ubuntu that we have. Now that doesn't actually convince me whether it is actually really a different computer than my workstation itself. So how do I do that? So here is my proposal. I want to shoot myself in the foot on this not on the workstation, but on this container. How do I do that? Basically, I'm suggesting that I will do a very, very dangerous command. Run it right now, right here. Something like sudo rm -rf, and I want to delete my binary, my etc, my lib, and just basically this is like shooting myself in the foot. And I'm going to say yes, go ahead, let's do it. And here we go. And now I cannot even run ls, and that's crazy, but that's what I just did. So I shot myself in the foot. But thankfully this was the virtual container, the Ubuntu container we started. So we can just simply exit out of it, and now we are back in business. We are still in business. We can again run another container like docker run -it ubuntu bash, and here we have a new container, and here everything is back in normal. The bin is there and etc is there and everything is working fine, and you can again go destructive if you like, but you got the point. Exit. So the container died. Now let us check. Docker ps. How many? We have 2 dead Ubuntu containers, 1 and 2, these guys. This is the ID and this is another ID. So 2 IDs, 2 dead. One exited 5 seconds ago, the other one 27 seconds ago. Now having created these containers, I want to illustrate this other point, which is I want to this time, instead of Ubuntu, I want to run CentOS. And here I have CentOS. How do I prove that? I will say cat etc/release. And this is the CentOS Linux, not Ubuntu, by the way. Let us quit this. I'm going to run another OS, another Linux variation. It will be, let's say, Debian. And we have Debian. How do I prove it? Cat etc release. And I have Debian reference, Debian Jessie. And that's what we got. Quit. And you get the idea. The idea essentially is that you are basically creating this reference that I mentioned before is here. On the same base kernel, you're adding this BusyBox image, and then you build the orange colored container. Whereas on the other end, the blue container, you can add Debian and keep adding your applications, and that becomes a separate container. But at the foundation is the common kernel, which is common to Debian and BusyBox. That's the idea. Back here, I want to now illustrate this concept of constructing a container and constructing our own images and essentially build out a 2-tier application. A 2-tier application will be, the example I will be having here is something like this. So in the first step, I want to have some kind of an application container that will run my application code. I will need to have some database container that will run, say, a database such as MySQL. And then I will need to also have a place to store my data corresponding to the database, which I am calling a data container. So it just stores the data, it does nothing else, strictly stores data. And those are the three things that I want to actually build images for. So the first image I will build using an image for data, and then I will build an image for the database like MySQL, and then I will build an image for the application itself. So the first one, to build an image for data, we can simply use something like this. This is a Docker file syntax. We are going to basically use Ubuntu OS as the foundation and use this as a volume reference to the MySQL var lib MySQL location. And that's pretty much the end of Docker file. So it's very simple Docker file, and we will use this Docker file in the data container, in the data folder here. This Docker file, we'll use that and construct an image like this. So we'll say docker build, and first we need to go to that folder location. I think I'm not in that folder, so I need to go to that folder, Docker files folder, and here I need to run this. And now I just quickly built this image for my data container. This is the image I will use to construct a data container. And now if I go check my images, Docker images, I have a new data image reference with this ID matching this ID which I just created based on this command. I did that in the Docker files folder for this data Docker file. Next up, what I want to do is use a existing image for MySQL database, and this Docker Hub already has one. In fact, you can see the Docker images listing. You see that there is a MySQL image 5.7, MySQL version 5.7, and MySQL latest. Both these images are already available on Docker Hub and have been pulled down in this workstation already. So we are going to just use them. In fact, you can say docker pull MySQL, enter, and it will go compare with what we have in Docker Hub with what we have locally. Everything already exists, so it did not pull anything, but since the machine image is already available, so I'm going to just use that image. There's not much change that we need to do to the MySQL database image. So this line, we don't need to create an image, it's already existing. We just use that. The third one, we have to create an image for an application that we may want to run. So for that, we need to have some application that you want to run. So here's an example Docker file for that. The idea here is that you want to run, again based on some operating system, Ubuntu here 14.04. Then you install some updates, install some applications you might have, some specific applications and packages that you want to load, expose some locations for the application directory, create some log files for the application to post some logs. And this is a example Docker file. And so once you have this thing in good shape, what you need to be able to do is build the application image. So you want to grab that docker build command and go and run it. And when you run it, this is going to build an image for your application that you have based on what you have defined in the Docker file. So in my example here, there is this reference to some installation. That is what is going on right now. It will build an image and then store the image in our Docker location here. So we can just use that image to run something if you like. And that is this Docker file is being used to construct a new image for our application. And that's what you're looking at right now happening here. It is running those steps that we have identified in our Docker file here. So you can see the apt-get is going on. And once this finishes, you will have an image ready for use with your application that you intend to use. And that way, by the way, we don't have an application, so there is nothing much to do here. Meaning, even if this succeeds, there is nothing productive because we don't have an example application in this example. There is nothing actually getting installed. So I'm going to break this and then actually use a real functional application that we can then operate on and see a real live demonstration. So in this particular example, I did not actually have an application to actually run. It's just a commented reference that you can install your application specific packages. And so having done that part, I'm going to make sure that I clean up. Before I clean up, the idea would be once you have these images constructed, you can then run a container corresponding to the data image. So for example, you have this data container you want to start, you will use this image you have, Docker images. You have the data image, that is what you want to use, and so you will create a new data container like this, and then you have a data container running here. So I think it's not running, it is dead, but it did run docker ps-a, and you can see that this data container exited 9 seconds ago, and that's what was this container instantiation. It created a container and then it exited. That's the whole purpose of that particular container, is to just create a place for you to actually put your data for the corresponding image, which is going to be your MySQL database. So the database will use the data image and the container derived out of the data image to store its data. Next up, we want to actually invoke a database container, which will be a reference to the MySQL image that we already have from Docker Hub. So here in this syntax here, you see that it is going to use the volumes from reference. This reference here is actually a reference indication to that data volume, which is here, we just created, which is this ID. And that is the volume that we want to use. The volume exposed from this container is used in the actual database container. And that reference is here in line number 11. Next, we are mapping some ports, 3306 for MySQL. We are setting some root password, a user, a MySQL root, MySQL password, MySQL data name, database name, a reference to a configuration file that is called out like this, and this basically allows you to bind to any address, so you can connect to the MySQL database from a different container. So that change you have to make in your MySQL configuration. And then you have a reference to the MySQL 5.7 image, which you already have locally here. And at that moment, when you're ready with this command to be executed, you invoke that command, and when you run it, it creates and sustains a live running database container like this. And you can see that although it exited, we had made sure that we run this -d option, which basically runs that particular container detached in daemonized mode. So you can see the Docker PS actually has this one container running live. This same one, which is matching your ID here, is the same ID that matches here, and that's the same container we just started. This is a database container. It runs MySQL. It is based off of the MySQL image from Docker Hub. It is exposing those ports 3606, and it is actually live and running, so you can actually connect to this database from your application. If you had an application, like in our case, in this particular example, we do not, but if you had it, you can just invoke it. Now, having done that part, I want to actually delete out these guys and go to a different example, which will be more interesting because it will actually going to be a live application. So this container that is running right now, Docker PS, I want to kill it. So the best way to kill is actually, I'm going to kill all these other instances of Docker PS-a that you see here. Lots of things that we have done up until now. I'm going to clean all of that. So I'll say Docker rm and then $docker and just kill every single thing. So now clean up. Docker ps-a should show nothing, and Docker ps should say nothing. Good. We still have our images in place. We have a data image, which is now constructed based on this command here, which is based on this Docker file here. We want to use that image in a next example. So we'll go to the next example, and in this example, we are using Docker compose command. So it's a comprehensive write-up, which basically refers to 3 distinctly different items here. First one is a data reference. In here, we are using that image called data, which is basically this one. That is the image which we have constructed already. Next, we are creating a database, MySQL, and we are setting some password for WordPress, which is an application I will be loading. We are exposing ports and taking a volume from this location. So that is where we are getting the volumes, the data volumes, and this particular portion here is the database container, which will use volumes from line number 12 reference to this line number 2. And so it will use the volume from data container in the MySQL container, and that becomes available as a MySQL database container. Next up, we are going to use a WordPress image also, which is available here. So we are going to use that image and then connect it up, link it up with the MySQL container, which is this one, and then pass the environment, WordPress DB password, and expose the port number 80, working directory defining to be this one, volumes mapping to our local folder. We will have a WordPress WP content folder showing up here automatically in this Docker WordPress example once we run the Docker compose up command. So I'll keep this window open for you to inspect, but on the same on the left side, I'm going to say clear and Docker cd to the right location, cd docker WordPress. And in this location, what I intend to do is use Docker Compose, which basically looks at these 3 different container definitions. One, which is the data image, uses data image. The second one is the MySQL container, uses a volume from the data container. And the third one is WordPress. This uses an image called WordPress and constructs its own separate container. You will see that happening right now. So I am going to invoke Docker Compose up. That's the only command, and you basically say Docker Compose and up with a -d option. So it will start these 3 containers, one for data, one for database, and the third one for the application, which is WordPress in our example. And then run all these 3 detached, daemonized like this. And now we have them running. We have a data container, we have the database container, and WordPress container, and they're all running. We can check them out, Docker ps, and we have these guys running here. And you will see that the data container doesn't need to be running, it needs to exist, and the volume from that is actually being used in this one. So the data container was created and it was dead. You can see that the dead container, Docker ps-a. You can see that the data container exited 40 seconds ago. And these 2 containers, the WordPress as well as the MySQL, they are still running. They're up and running here. As you can see in this listing, Docker ps will show you a listing of all the up and running containers, whereas Docker ps-a will show you all of them, including the dead ones. So this guy died, and that's okay. We just want to use the volume, and we actually want to use that volume like this here, this reference volume from reference, and that is what this container is using, the volume from this container. And then WordPress, which is also here, is connecting to the database, and WordPress itself is exposing port number 80 on our local host, which means I should be able to open a browser and say, show me what I got. And there we have it. Bingo. And we can say Cloud Genius and we say Nilesh, and then copy the password and then put my email address here and say install, and off we go. So we can log in with the name Nilesh and password and say login, and here we have our WordPress loaded up and running. And this WordPress is using the database here, and the database itself is using the volume from the dead container. And that's the demo. Now let us understand what we just did. What we did basically is we ran 3 different containers in form of a data container, a MySQL database container that uses a volume from the data container, and then also had our application, which is the WordPress application. So what we had essentially was something like this. So let's get rid of the fourth one. We had a data container, so this was just the data. We had this container running MySQL image, and we had this container running WordPress, and we linked them up together so that this guy WordPress gets exposed to a browser. The WordPress container itself connects to a MySQL container for database access, and this container uses the volume from this data container which we created. So these 3 containers we created. You can reproduce the exact same thing based on a sample that you can download from a link below here, and that is what I would recommend that you please do, so you get a good solid feel about how to actually make use of these things. By the way, we have a new program running here which is using Ansible for Cloud DevOps. That's going to be released shortly on our site. We already have 3 different programs that run for our customers, primarily focused on, one of them is Cloud Technologies, which basically studies from an industry neutral, vendor neutral perspective, focusing on open source, what technologies are out there available, software as a service, platform as a service, infrastructure as a service. And that program is also available as a part of our online bootcamp that runs just like this, like a video conference with our participants worldwide. In addition to this one, there is another program focuses on cloud DevOps using Chef and Ansible. That goes quite a bit in depth in terms of using these technologies, Chef and Ansible, in administering, operating, managing the development operations, and orchestrating a cloud-based service out to your customers. That's the focus on the Cloud DevOps program. We also have a third one which focuses on a slightly higher. So it basically takes the learning from these 2 early segments, which is the technology segment, which goes in a breadth spectrum. The DevOps segment goes in depth with one particular technology, and we apply the learning from these 2 in understanding what architectures or architectural blueprints might fit a particular given customer scenario or a business scenario your company might have, and that's the focus behind this cloud architecture segment. Our programs run on video conference. They also run sometimes in companies or offices, their locations, wherever you want the program to run. It will run for your location if you require that. And let us summarize what we just did. So we took a sample that you have available to you. You have a workstation available to you. You can run exactly what I just did. You can follow along. This video should be available for you to view later on. I will provide a recording to you guys, and try that sample, get a solid feel of what containers are going to do, and this is a case where you can actually put these to use in real life. If you have any questions anytime, you feel free to ask. I'll answer them. I already see some questions coming here. One of them was this aspect of using the tool set directly on a Windows workstation. I think that may be possible through a tool, but you need to set it up. The easiest way would actually be this workstation. You just download it from here. It already has been set up. So what you need to basically do is first, on your Windows machine, install this software, which is Oracle VirtualBox. And so you can get it from here. And for Windows OS, you can get from here. Once you have that VirtualBox loaded up, then you can come back here and download this workstation, which is a large OVA file. And you can just, once it downloads completely, there are 2-step process to downloading the OVA because it is a large file download. But once you have it, you can just double click on that OVA file and import it inside your virtual machine, and that will get you this workstation that I was using and then you can also download the code and get to the point where you want to actually experiment with these things. Let me see if there are other questions here. Okay, so there is a question about when are these courses starting. So I think the best way to check those details are actually on our website. So best way to go find out is on the site. Look at when the next program starts, and if you find a date, you can just chat or maybe fill a form there and just get in touch with us, and we can connect with you. We have programs sometimes running in other cities such as Chicago, where we have a university, Northern Illinois University, that runs our programs occasionally. So NIU runs our program here in Chicago, and you can participate there in that location if you are in that location. We also run it in Kirkland location with Lake Washington Institute of Technology. So if you're an employee of a company like Boeing or Expedia, you can probably get reimbursed for programs that you study in Lake Washington Institute. If you're a Microsoft employee, I think they also reimburse that. So based on whatever company, whether your company sponsors it, we have also the Washington State government career bridge. Washington State government also reimburses if you have a job loss. Washington State will actually reimburse. Our program is eligible for reimbursement, this ETP eligibility, and that program is available for all the programs that we have are eligible for reimbursement through, I think this is called WorkSource, if I remember right. This is for people who are out of job or facing a transition of jobs. Washington State does provide help, financial help, and so you want to explore that as an opportunity if you have that situation. We also run programs for U.S. military. In fact, we have run that already. Here is a group of people that graduated. These are our soldiers coming back from Afghanistan, Iraq, wherever they were. Now they're home, and these guys want to get training. They want to get a solid understanding of what cloud computing is. So it's a customized program just for them, is what we just did for our soldiers at the Joint Base Lewis-McChord. Let's see, what other questions do we have here? I think there are some other questions. I will answer to these questions. They're probably more hands-on. It requires further one-on-one. So I will do that separately with you guys. And I think let me get back to you on the chat where we can actually walk you through. There are some specific things you want to discuss. I'll come back to you on the Slack chat. And with this, if there are any questions, keep them coming on the Slack chat, or any other email is also welcome. Connect with me on LinkedIn if you like. And I want to thank you. Cloud Genius has been the fastest way for you to be productive on your job with cutting edge technologies primarily, and the feedback that our graduates have been giving has been truly amazing. So I want to thank all of our graduates and all of you interested in Cloud Genius. Thank you very much.